Ever wondered how Netflix recommends movies you might like? It's not magic, it's machine learning, a field of artificial intelligence that allows computers to learn and make predictions based on data. It's like teaching a child to identify animals. You show them pictures of various animals, and over time, they learn to recognize them. That's the beauty of machine learning. It aims to create systems that continually improve, much like a child learning new things. Machine learning, in essence, enables computers to learn from experience. Diving into the world of machine learning, we encounter several key concepts and components. At the core of machine learning is data. We have training data, which is like the textbook for our algorithms. It includes pairs of inputs, the data our algorithm uses to make predictions, and outputs, the results we want it to produce. After the algorithm is trained, we test it on a separate set of data, the testing data. This helps us assess how well it can apply its learning to new, unseen data. Now let's talk about the teachers, the algorithms. These mathematical models or rules guide the system in learning patterns from data. We have supervised learning, where the algorithm learns from a labeled dataset, like a student learning with a teacher's guidance. Then there's unsupervised learning, where the algorithm finds patterns in an unlabeled dataset, learning on its own. And we also have reinforcement learning, where the algorithm learns to make decisions based on feedback, like a child learning to walk, falling, and standing up again. Features are the individual measurable properties of the data, like the distinct characteristics of a person. Choosing relevant features is crucial for a successful machine learning model. The learning happens during model training. Just like in school, the algorithm iteratively learns the patterns and relationships within the training data, adjusting to minimize the difference between its predictions and the actual outcomes. After training, we validate the model on a separate dataset to ensure it can generalize to new data. This process, along with testing, helps identify any potential overfitting where the model has become a little too good at memorizing the training data. Evaluation metrics are like report cards. They measure the performance of a model. Common metrics include accuracy, precision, recall, and F1 score, among others. Hyperparameters are the settings we decide before training. They're like the rules of a game, defining aspects like the learning rate and the number of hidden layers in a neural network. And finally, once trained, tested, and validated, the model is deployed, ready to make predictions on new, real-world data. Once trained and validated, a machine learning model stands ready to make predictions on new, real-world data. The applications of machine learning are as diverse as they are impactful. From recommendation systems that curate personalized content, autonomous vehicles navigating complex terrains, to intelligent systems in healthcare predicting diseases, and finance forecasting market trends. The effectiveness of these applications is not by chance. It's a result of quality data, the right algorithm, and meticulous tuning of parameters during training. Machine learning, therefore, holds immense potential to transform the way we live and work, one prediction at a time.